Forget little green men and flying saucers. The next big alien discovery won't come from a telescope spotting a metal ship. It'll come from a chemical spectrometer. We are currently on the cusp of an interstellar revolution. Right now, molecules like phosphine, or even stranger exotic compounds, could be screaming life across the vacuum of the cosmos. Today, we're investigating the elusive chemical fingerprints of extraterrestrial life. We're moving beyond simple oxygen to explore the complex biosignatures that could finally prove we aren't alone. When we think of life, we think of breathing. On Earth, oxygen is our smoking gun. But searching for Earth-like life is a massive assumption. Here's the thing, oxygen didn't even exist in high levels on Earth for the first couple billion years of life. So using it as our only benchmark means we'd miss our own planet's early history. What's more, on a planet orbiting a red dwarf star, high-energy radiation hitting water vapor can produce oxygen without any life at all. That's a classic false positive. This is why scientists are now expanding the search. We have to stop looking for our mirror image in the cosmos and start looking for chemistry that just shouldn't be there on its own. It's a fundamental shift in how we hunt for our cosmic neighbors. Let's look closer to home for an example. In 2020, the scientific world absolutely exploded when phosphine was detected in the clouds of Venus. Now, on Earth, phosphine is only produced by two things: industrial processes or anaerobic bacteria. That's life that thrives where there's no oxygen. So seeing it on a planet as harsh as Venus was a total shock. The debate is still raging. Is it a volcanic fluke, an unknown abiotic chemical process, or is something actually living in those intensely acidic clouds? Venus has become our reality check. It challenges our cozy notions of what a habitable world looks like. It proves that a planet doesn't have to be pretty and blue to potentially be biologically active. Sometimes the most interesting clues are found in the most hostile places. So if not oxygen, what are we looking for? Scientists are on the hunt for things like methane, ammonia, and various sulfur compounds. But the real key isn't just one single chemical, it's a state called atmospheric disequilibrium. Think of it like this: if you put a single drop of ink into a glass of water, it eventually spreads out and the water becomes a uniform light color. That's equilibrium. But what if you looked at that glass and the ink was constantly forming a perfect dark circle in the center, never mixing? You'd know something was actively working to keep it that way. In a planet's atmosphere, it's the same idea. When we see chemicals that should react with each other and disappear like methane and oxygen together, but they're both constantly present, it means something is actively replenishing them. And that something is very often life. We're even theorizing about bizarre, silicon-based life forms and the weird, sandy chemical footprints they might leave behind in an atmosphere. The goal isn't just to find one molecule. It's to find a chemical imbalance that screams, "I'm alive." How do we actually see these cosmic smells from trillions of miles away? Enter the James Webb Space Telescope and other future observatories. They are our ultimate chemical detectives. By using advanced spectroscopy, we can watch as a distant planet passes in front of its star. The starlight filters through that planet's thin atmosphere, and the chemicals present absorb, or eat, very specific colors of light. By looking at the missing pieces of that starlight rainbow, we get a chemical barcode, a precise list of the gases in that world's air. The biggest challenge, of course, is avoiding another false positive. We have to be absolutely certain that a volcano or a powerful solar flare didn't create that methane before we call a press conference to announce we found neighbors. It's a game of cosmic CSI and the stakes couldn't be higher. This search isn't just for astronomers staring through telescopes. It's a massive, unprecedented collaboration between astrobiologists, chemists, geologists, and physicists. We are designing missions right now. Spacecraft specifically engineered to sniff alien air and analyze its composition with incredible precision. If we find that unique chemical fingerprint, a signature of disequilibrium that can't be explained by rocks or heat or radiation, the implications for humanity are profound. It would be the single most important data point in all of human history. The proof that the spark of life isn't a miraculous fluke confined to our small blue world. It's a universal constant, woven into the fabric of the cosmos itself. The search is on, and the next discovery could change everything. Thanks for watching. If you enjoyed this journey, be sure to subscribe for more deep dives into the mysteries of our universe.